So the topic of today's session is from data scientist to manager. In other words, Luigi and Louis episode 2. That's a fun name that Luigi came up with. And episode 1 was in December. So these are some of the topics we talked about. And so on the same platform, Crowdcast. So it's good to hear people's feedback. Apparently people liked it. It's also good to hear your questions. So there's a poll. You can let us know what sort of your background is, or the poll actually asks you what is your main role. I'm trying to set up polls for these events, and this time it's just one question. So it's good for us to sort of know a little bit more about the audience, since we can't see you guys. I mean, even if you could see you, we wouldn't know what your main role would be. But anyways, today's conversation is going to be about this. We're going to talk about what a machine learning project looks like from idea to deployment, the daily workflow of a machine learning manager, how to expand a data science practice, build versus buy, which to choose. Is the answer as simple as buy SageMaker, or is it going to be more complicated, Luigi?
I think in the past couple of months, it's become more complicated for me, at least, depending on what exactly you're trying to do. So it's definitely a worthwhile discussion to have.
So for anyone who's wondering, the reason I'm mentioning SageMaker is that I think that this is how we got to know each other, Luigi, when you started this course, this SageMaker course, but you've moved on to new topics of interest since. So yeah, I'm curious to know your thoughts on that, but we'll get back to that.
Sure.
There'll be time for Q&A. So what you guys can do at the same time as we're chatting is that you can use the questions tab at the bottom of the screen to ask your questions, and then if they're good questions, they get upvoted, and we try to cover them by in the order of most upvoted first. I'm curious to know a little bit more about what I was talking about in the description of this event. So I introduced you, Luigi, as obviously the founder of Machine Learning in Production, mlinproduction.com, but also you were working as a data scientist, and you transitioned to a management position. Right. And that was last year. And I'm just curious to know a little bit more about the details. How did that happen?
Sure.
How did you end up, being a manager and making that transition? And what does it feel like? What are the biggest challenges that you had? What brings you most satisfaction? Those sorts of things.
Yeah, absolutely. So I actually transitioned to being a manager almost 2 years ago now. So it was about the summer of 2019. And I had been an individual contributor at the time, just a data scientist who was focused, sort of an end-to-end data scientist, right? I spent time doing data analysis and building machine learning models, but also deploying those models to production and looking at end-to-end pipelines. So everything from raw data extraction in databases to ETLs for feature engineering to model training, inference, scoring, and monitoring on top of those pipelines, both for batch cases and for real-time cases. And that, emphasizing those end-to-end pipelines and the work required to productionize systems was really what led to my building ML in Production, which is a blog and newsletter. I did a course, some live courses, focused primarily on what it takes to actually take machine learning experiments out of Jupyter notebooks or out of R Markdown files and put them into production pipelines that get integrated into technology products. So I spent a lot of time researching that work, writing about it. And primarily it was more of a learning vehicle for myself than anything else. I had spent a fair amount of time in a couple of different jobs doing various work related to different parts of an end-to-end pipeline, but I wanted to sort of fully shore up my knowledge there and really understand what the best practices in the industry were. And during the course of my research, I found that there weren't very many best practices. At the very least, there wasn't a sort of centralized place where you could easily learn what the best practices were. So I started that blog primarily to act as that centralized repository of best practices for production machine learning. And it wound up taking on a life of its own and had some, there was a lot of interest in it, relatively speaking. After a while at 2U, which is the company I still work for today, we started expanding our practice slowly, and it made sense for me at the time to take on a more of a leadership role within the team. I think I had demonstrated that I had a particular vision, and it was just more than me wanting to do individual tasks and that sort of thing. And I wanted to grow my career, and not that going into management is the only way of growing your career, but I think that's where I saw myself going long term. So started out by just managing a new junior data scientist. Did that for a while, and then started sort of essentially transitioning other data scientists that I had worked with under my sort of direct reporting line. That continued. We continued to grow the team, and as it stands today, I'm managing 5 data scientists, and essentially all of the machine learning projects that go on at 2U, which is a public company. It's traded on the stock exchange. It's doing quite well, and it's on its path to becoming a $1 billion company. So that's essentially the transition. Cool. It sort of happened slowly, but as I got more experience and as I became more familiar with what it really took to excel in the role, we just started essentially moving more of the team's operations under my guidance, essentially. And I'm happy to speak more about the challenges there.
Sure. I'm also curious. So you said that you've got a team of 5 data scientists. Can you give us a sense of how many projects you're overseeing, how many different projects with different and also I guess I'd be curious to know what sort of phase each project is at.
Sure. So at one point we were running probably around like 3 to 5 production systems. So they were in relatively different stages. I would say half of those were production systems that the company relied on every day, and the other half were sort of research style projects that were intended to become production projects. We tried to sort of seek this balance where we weren't spending our full time on operating or maintaining systems. We were also allowing for time to explore different experiments or different new projects that we thought might have a lot of value in the future. So we tried to split our time as much as possible in building and running systems that the company needed and that we had already proven out success with, while at the same time still saving time for exploring sort of blue sky ideas and ideas from submitted from either stakeholders or even ideas that we thought would be interesting to explore. Right now, those production projects are still in production. We're still running those systems, and the 2U still depends on those systems. But we've taken a little bit of a different approach and decided to sort of slim down the number of additional projects we take on, but with a focus on projects that we know for sure are going to have a lot of value, depending on the sort of ability we're able to demonstrate in predicting particular targets or running particular sets of experiments. So we're still very much running new projects, but our focus has been pared down so that we focus sort of on a small number of ideas that no one else in the business is really sort of incentivized to approach, perhaps because of the organizational structure or perhaps because of the skills required on those projects, and for us to really focus on those things and own them end to end. So I think we're probably in the most exciting possible day of data science at 2U right now.
You mentioning the sort of the business value of different project ideas. Can you tell us more about how that works in terms of prioritizing ideas? I guess that you want to have a look at the technical feasibility. You want to have a look at the potential impact. Is that something that are you interacting with other sort of other managers, business managers, or how do you sort of agree on or align with what are the company's objectives? What value are you trying to create for the company? Those sorts of things.
Yeah, I think that's a great question. I think this is really where it pays to you either have very strong relationships with other business stakeholders, or you have a chief data scientist or department head who's very much embedded within the senior most executives at the company. And this person's job essentially is to understand what the strategic initiatives of the company are and what the real challenges of the company are. And what this person is able to do in this case, I really rely on the chief data scientist, who is above me, let's say, at the company. He is very much works very closely with the COO, the chief marketing officer, the chief operating officer, and the chief financial officer and chief executive officer, and he understands very much what the goals of the company are in the next 1 to 3 to 5 years, right? Mm-hmm. And what he's able to do is bring those strategic initiatives to our team, and essentially communicates to me and to and to folks on the team what the goals of the company are. And it basically falls on a combination of the managers to translate those strategic goals and those strategic ideas into concrete projects that we can then carry out. So I think we've been the most successful in building projects, running projects and building products when we're as aligned with the business as possible. And in my experience thus far, I found that having a manager, having a department head who is neck and neck or elbow and elbow with the senior most executives, really gives us that possibility. So we've had other patterns as well, where, for instance, we've acted as a little bit more of like a consulting shop, just going to individuals within the business and sort of seeking out ideas and having conversations and building out prototypes and then trying to get a little bit more buy-in from those teams. Sometimes that worked and sometimes that didn't work. Sometimes, oftentimes that was actually quite frustrating because a lot of my time when I was running those types of projects was spent in selling the products that we built to the various teams, right? There's sometimes some resistance across individuals outside of data science to adopt the products that data science builds. And I think there's good reason for that, especially when the incentive structure is such that the team who we're selling to would be responsible for a failure, whereas the data science team, might not take the sort of, if something were to go wrong, it may not look as bad on the data science team as it does on the operational team or the business team. So there are challenges there. We've also tried to sort of do what I like to call what one of the people I work with likes to call the cowboy model, where we just look at the ideas and just build the thing ourselves and just try to run it ourselves. So not get as much executive, not get as much business sponsorship or business buy-in. And we found that has, very low success rate, let's say.
Okay. But when you're trying to sell these ideas, is that you on your own with your team of data scientists, or do you get help from the chief data scientist? How does that work?
So when we were doing that, I would say we were under a little bit of a different organizational structure, a leadership structure. So that was mostly, myself basically taking the products that my team had built or that we had been building for some amount of time and trying to essentially understand the stakeholders, different sets of stakeholders' needs, and perhaps trying to adapt our product to fit those needs. So we may have built something that had an original purpose, and that original purpose sort of didn't pan out, but we still wanted to derive some value from the products we built. So we tried to sort of adapt them to the needs of stakeholders who had similar enough problems or challenges that they needed to overcome. So one example could be you build like a forecasting system, right? And the forecasting system may be very useful for the finance team, but you may also be able to get some value out of that for a marketing team, right? Depending on exactly how that forecasting system is built. So we had a couple of projects like that where they were originally built for a particular goal, but companies change, teams change, leaders change, especially as our business was one that went from, only went public, let's say in 2014. So, there's been a lot of change over time, and it's been growing, it's been acquiring other businesses. So, staffs change very rapidly in that sort of environment. So, you may start out building a project for a particular team, but then, as you progress, the executive sponsor may not even be a part of that team in a couple of months,
right.
for whatever reason. So, we want to take all that work that we've already, put into the project and still try to get some value out of it. So I think those were the sorts of situations where we were really trying to shop things around more often. And I'd say now we're doing less of that, and more of just taking a vision from somebody, from the department head, let's say, and really carrying that out and really heads down focused on building that vision. And we still have to invest a lot in relationships, in things like transparency, how our models work, what sort of features are going into the models, what's the performance of those models, how are our experiments running, what are the types of things we're seeing. We have to do a lot of explaining, but I would say that investment just continues to build on itself, and you just get more and more confidence and a stronger relationship with your stakeholders. And so we have to do really less. I have to do really less selling and more of just explaining. And I find that, like, I'm enjoying my role a lot doing that, because sort of maybe the hard work is already done for us, right? And the hard work being making sure that we're focused on solving problems that people actually want solved, that there's actually a need. And when there is actually that need, it's, people are knocking on your door for the product, right? People are saying, like, can I have this yesterday? Rather than, oh, this might be nice to have, or, I could see us potentially using that. Now the situation is such that, people want what we're giving them ASAP, and more.
You were talking about changes in the organizational structure of the company. I'm wondering if that position that you have, director of data science, did that exist before? Was that created when you started the job?
No, that position existed before.
Okay. And the chief data scientist, how long has this position existed at that company?
Well, it's existed for quite a while. It might have gone under sort of different guises, but there was always a department head, let's say.
Okay, right. And if we go back to you transitioning to that role, I think I have like one last question on that. Is there any particular advice you would give to someone who would be, also interested in making that sort of transition?
Yeah. I think you can approach that question from a lot of different angles. I've been reading a pretty good book. I forget the name of it, but I think it's written by. I'll have to. It's written by Camille Fournier, who is a sort of a CTO at a pretty large tech company. I forgot exactly the name of the tech company, but I can. If I'll write in the name of the author here, Camille Fournier. I think it's a pretty popular book, but essentially in that book she talks about technical management, more from like an engineering perspective management, right? And she essentially talks about what it means to be a manager at sort of every level of the organizational chart. But what I like about the book is that she starts out talking about what it means to be an individual contributor, and to be an individual contributor who is easy to be managed, let's say. Right, there you go, the manager's path. Exactly, that's the book. Thanks, Joe. So, cool. Although the book is about management, it really starts out from the perspective of somebody who's an individual contributor, right? And what it explains essentially in that chapter is, what does it mean to be somebody who a manager really enjoys managing, right? Or somebody who, it's a pleasant experience for the manager, right? And from there, it then goes on to speak about what it means to be a team lead, where a team lead may run a project but doesn't directly manage anybody. Right. So this person still has leadership responsibilities, but the oversight expands over a project rather than over other individual contributors. And then sort of the next level of management is a manager of individual contributors. Right. So why I bring up this example is because there are very clear things that you can do at the individual contributor level or at the team lead level or at the project lead level before you become an actual manager of individual contributors. And I would say probably like no phrase captures this better than the phrase of thinking like an owner, right?
Mm-hmm.
And what does it mean to think like an owner? Well, it's not enough to just finish a task, right? You get a task assigned to you, and maybe it's you have some project management system, and you complete the task, and you call it a day. That's not enough, right? It's you need to have so much ownership and responsibility and personal accountability for the task that you are going to do whatever it takes to make sure that that task is done. And if there are any issues that pop up, and issues will pop up from time to time, that it is on you to make sure that you do whatever it takes to make sure those issues are taken care of, right? So, if you're, for example, if you're the owner of a business, if you're the CEO, and there's some task that nobody else wants to do, it's on you to do that task, right? And you know that that's the case. Now, of course, it's not as I'm not saying that's what needs to happen as a data scientist, but have you done the double checking of your analysis? Have you stated all of the assumptions in your analysis? Have you checked with stakeholders to make sure that how you're interpreting the data is actually correct? Are you taking those extra steps to make sure that your analysis is a responsible one, right? I think from a technical perspective, those are things that you should be able to start doing. You shouldn't be sort of satisfied with, I did some exploratory data analysis. Here's my report. That's the end of the story. And that's just on the technical side. On the sort of project and people management side, I think the best place to start is in really sharpening your communication skills, right? Communication skills are very important for data scientists in general, regardless of if you want to pursue a path in management or not. But at the end of the day, you already have a lot of opportunities to actually practice your communication skills, right? Can you explain your analyses to coworkers, technical coworkers, your other data scientists on the team? Do they understand what you're trying to explain? Can you explain your work to non-technical people? Can you explain your thinking process behind your work, right? Because a large part of actually managing people is, let's say, taking some goals or some vision or some idea and translating those ideas into technical things that you actually need to build, but then convincing and persuading people that these things are worth doing, right? I think that the thing I enjoy most about management is you get to really take advantage of people's ability to do great work. And I don't mean take advantages in a bad way, but I mean with some investment of time and motivation on your part, you can see a project go from just an idea to like this beautiful product that gets used by thousands or tens of thousands or millions of people, right? And what it takes there is what you're not actually doing that you might not actually be doing the technical implementation, for example, writing the code or deploying the model, but you are inspiring the individuals on your team who are doing that work. And I think that's what I enjoy most about the role, which is being able to, whereas previously sort of the keyboard and the code and the libraries were the things I worked with to accomplish particular goals. Now the things I work with are individuals, right? And they're much more dynamic and capable than scikit-learn is. If you can understand how to work with those tools, which are people, very well, you can really build great things. Now, like working with people is significantly more complicated because you get into things like motivations and personal relationships and those sorts of things. But in my opinion, it's extremely motivating and extremely dynamic.
Cool. Yeah. Great to get your take on this. I think that one of the things that we should also talk about is the okay. I want to speak about your daily workflow to sort of get a better feel of that, but also maybe before going into that, One of the things that we discussed just before we started this call, well, before we went live, was these different frameworks to manage machine learning projects or data science projects. And I think I'm going to run a poll to sort of get the audience's take on, what tools they use, what frameworks they use, and so on. But so one of the frameworks that you mentioned was, so maybe, getting back into more technical things. You mentioned CRISP DM or ML, I can't remember which version.
Yeah, I think I mentioned CRISP DM or CRISP DMQ is one of those frameworks.
Right, which sort of as these different phases, explains what the different phases of a data mining project is, or CRISP ML of a machine learning project. And the addition, I think, with CRISP ML is just the monitoring phase. Actually, that relates to maybe what you said about owning the problem. I'd say all the way to monitoring and making sure that it stays healthy and it works well throughout time. But okay, so I'm curious to know if what are the phases for you? Like, what does a machine learning project look like? What are the different phases you transition through from
Sure.
The point that you I think that what I said in the event description was from idea to deployments, but I just said that something else after deployments, which would be monitoring. Would you say the same thing as the CRISP frameworks, or do you see things differently?
Yeah, I think those frameworks are all good places to start. And I think for the most part, when people compare and contrast them, in my opinion, I don't really know how valuable that is, because I think they pretty much all say the same thing, right? I try to just abstract away. I think it's, whenever you come across these types of things, I think it's valuable to read all of them, right? I'm just an avid reader, so I just like to consume as much information as possible, and then try to synthesize it a bit and see what I think makes sense. But I think things like CRISP DM, CRISP ML, TDSP, there's a few others out there. They all essentially say the same thing. Things start out with this like business understanding phase, right? What is the problem that you're trying to solve? What is the goal that you're trying to achieve? And from there's sort of this exploratory data analysis phase where you actually get your hands dirty on some data. There's a feature engineering model building phase, some error analysis. Then there's the deployment, and then there's the monitoring. There's sort of the operational maintenance piece of the project. So I think those are the major stages, and I don't think those really differ very much from process to process. CRISP DM is a little bit older, and the transition from CRISP DM to CRISP ML was really about sort of plugging in those last couple of stages around like having an actual application and having monitoring on top of that application, rather than just having a model's outputs, which may have been enough in a previous time. So, add those stages, but essentially they all say the same thing. What I like though about these frameworks is that they give you that template. They give you that idea of you should be doing these things. Now, what's different about these frameworks over something like Agile is that they're much more nonlinear, in the sense that you might hop from stage to stage based on what you learn. So you're not really expected to go directly from business, to go from business understanding to EDA to model building to deployment and monitoring, and then you're done. You might start out with some business understanding, generate, do some exploratory data analysis, generate some hypotheses, go to the model building phase, and then see that your models aren't very performant. Right. And if your models aren't very performant, it doesn't make any sense to actually deploy the things, because it's not achieving your business goal. So what might you do from there? Well, you might go back to the feature engineering stage and try to develop more features. But if that doesn't work after a couple of iterations, you may actually go back to the business understanding phase and say, hey, we actually don't think it's possible to predict these targets at the level of predictive performance that's necessary in order for us to achieve our goals. Can we update our problem statement in such a way as to perhaps predict this other target that we hypothesize is actually a little bit easier to predict, and we can do a little bit better than that, right? So even though you're using these phases, what's interesting about them is, if you were to basically build like a topological map of a graph with these phases, they're almost all connected. Every stage is almost connected to every other stage, right? It's the most like complicated network topology possible, because you can almost hop from any stage to any other stage depending on what you learn there. So it's really about being prepared to essentially go back to the starting board if you need to, or if you're finding that your models are doing really well, your baselines are doing very well, even, you can skip ahead to the deployment. Perhaps if you're able to really derive the value from a little bit of work, I think it's prudent to take advantage of that and to not spend too much time in the model building stage adding unnecessary complexity, for example.
I think that relates to one of the rules of machine learning from Google. For those of you who are not familiar with it, just Google rules of machine learning. And one of the points is that try to do it without machine learning and see what happens. And then, if it works without machine learning, then, that's great. Maybe you might be able to, get further improvements, but, already you can deploy something that works and that brings value. So yeah, like that point as well.
I think I could say one more thing here, if you don't mind. That
sure.
When I approach these projects, when I was I'd say starting out in the field, my mind immediately went to, okay, what kind of model can we build? Like, how can we build the most predictive model, right? And now when I'm faced with a new project or product to build, my mind immediately jumps to, how will the predictions need to be served at runtime? Like, that's almost the first question I think about after the business understanding phase. After we understand like what we want to model, my mind immediately jumps to, how are the predictions going to actually be served?
Go ahead.
Yeah, is it going to be some batch system? Is it going to be a real-time system? Can we cache the results before the results actually need to be served? Because what that has major implications on is the end-to-end pipeline. Because you may be able to very easily host some model, as an API endpoint, maybe just as a microservice. But the challenge is not hosting the model as a microservice or as an independent entity. The challenge is getting the necessary data to that model to generate the predictions. What I mean by that is, some models can be real-time models, and the data that's going into the features actually all comes from the request to the model itself, right? It's just some user request, perhaps from a web form or something, and all the data necessary for the model is in that request. Other models will require some combination of data from the request and and also some data that's very easy to query from some persistent data stores, like a SQL query. Okay, that's a little bit more complicated, but that will require more work on the pipeline. And some other models may require data from the incoming request, which is easy to get, data from a simple query to run, which may also be easy to get, but add latency to the actual inference process. And some other data may need to be queried, may be much more expensive to query. And what I mean by that is that those data points may actually be the results of complicated batch ETL processes that needs to be run perhaps over the last hour of all data accumulated, right? And when you need to do that, you're going to actually, if that data is easily available, that historical data is easily available, when you're building your models, it'll be easy to build a very performant model, or not easy, but you will skip over the work required to actually compute that data on the fly. Whereas if you were to invert the problem and think about that first, you're going to think, well, damn, it's going to be very hard to generate that data on the fly. And deploying the model is not going to mean just deploying this single sort of binary file. It's going to mean setting up complicated batch ETL processes that have their own probability of failure and need to have their own monitoring and operational teams devoted to them.
I think there's this article by Jeremy Jordan that I read that you shared and that I look at, which sort of recommended to, maybe just start like as soon as you've defined the problem, write a heuristic and then shadow deploy that. And then that gets you to think about these things as well. The way that I would so the question I would ask to sort of get into the same mode as you is very similar. I would just ask, what is the I imagine I already have a perfect model. What next? And that also, I think, gets you to think about whether sometimes you predict something that sounds really cool, but how do you convert that to business value? Like, what do you do on top of these predictions? What decisions do you do on top of these predictions to sort of provide that value? So I think it's a very good thing to ask yourself before getting too deep in model development.
Yeah, and to your point about Jeremy Jordan's article, I love Jeremy's articles. I've sort of, I like that perspective of setting up the simple heuristic that you shadow deploy first. But I've found that not that it rarely works, but I find that organizationally speaking, often the pressures are to put out something a little bit better than the heuristic.
Right.
I think when you are able to put out the heuristic, it's more from the sense of you're able to monitor it on the back end, but those outputs aren't really being used by other teams or by other systems. That's where I found that sort of, build something simple, deploy it, and monitor it to work very well. But I think oftentimes there's a lot of pressure to put out a system that at least meets some minimum level of predictive performance, and the simple heuristic may not actually reach that level of adequate performance. Although I do think it's something I strive towards. I just found that in practice it hasn't worked out as well or as seamlessly for me to do that.
Interesting. Cool. So I created that other poll to ask about everyone's frameworks that they've been using to manage their data science projects. There were a few. Thanks for the additional votes. There's one more TDSP. I mean, there was 0 TDSP. Now there's 1 TDSP. Other agile methodology. I'm curious to know what you guys are thinking of. So please share more via the chat. I think that's interesting for everyone to have a look at that. I would have thought that there would have been more TDSPs. Crisp DM or Crisp ML seems to be more popular. But
this is something I have a lot of opinion on. Not whether to use TDSP or Crisp DM or ML or something else. It's more on, do you use something or do you not use something? I think this is like this binary flag is a good predictor of sort of how many projects a team might actually have deployed, or how many products teams might have deployed. Because I found, at least in my experience, going from not using a framework to using a framework just led to significant productivity and efficiency gains in the team, because it was much easier to define what people should be working on. And in my team, I like to run sort of regular check-ins where, I ask people how satisfied they are, and, both on an individual basis and also as a team. And I was very surprised by how much more satisfied people were when we adopted one of these processes. They found that they enjoyed the structure much more. One of the process that we adopted, which is TDSP, that was, I voted for TDSP here. We don't, it's not that we follow it sort of like religiously, but what I like about it is that it gives you sort of milestones and artifacts to create, and creating those things gives both a sense of achievement for the individual data scientist who, many experiments aren't successful. And at the very least, when you run these, when you create these artifacts, you have something to show for your work, and much more. So from a personal perspective, that's very beneficial. But from a team learning perspective, you can look back on these artifacts and do a sort of like meta level learning on how the project has gone over time. And I found before that, you, for example, on any given project, you may be doing a lot of different analyses, and these things often just get lost in code repos or side branches. And you can, in a couple of months, you can't even draw from that knowledge. And especially if somebody leaves the team who did all that work, essentially the knowledge is gone. Nobody's going to look through previous analyses, especially if they're, not well organized. And oftentimes you have to create so many analyses that it's hard to come up with a good organizational system for them. But what TDSP does for us is allow us to generate these sort of markdown files where we explain our exploratory data analyses, where we explain our models. I make sure that every model we build, people put significant work into an error analysis for those models. I care much more about the error analysis than I do about the hyperparameter sweeping, for instance.
Yeah.
So, once they build these models, we have, very nice output showing what features went into the models, what the metrics looks like, what more detailed error analyses looks like. And that benefits both the same data scientists in months from now when they go back to the project or try to improve on the model, and it also benefits junior data scientists who want to learn how to do these things better. So
right.
I think we've had huge benefits from adopting a process framework over no process framework.
Yeah, I like that. It comes also with, TDSP can be quite complex, but it comes with sort of this template that sort of gets you to see more concretely what these markdown files are going to look like. So yeah, probably just Googling TDSP, or you can also search for TDSP on GitHub. I think that you'll find some interesting stuff there. Cool. It's already 10:02. Should we have a quick look at the questions from the audience? There were other topics that we wanted to talk about, but I think that it's fair to maybe take a few questions from the audience. If you've asked a question, have a look at the other ones and upvote those that you like the most. If you haven't asked a question, you can do the same. But yeah, obviously it makes sense to upvote your own questions, but also votes others that you like, and then we'll use your votes to sort of prioritize these things. Thanks for everyone who shared links, and Joe for sharing. That looks like a great book. I didn't know that book. I want to read it definitely. And thanks Hafiz for sharing that TDSP link. Should we start with the first question? Can you see the questions,
Yep.
Luigi?
Yeah, let's do it. We have we don't have much time left, so let's get to these questions.
So do you still do any hands-on work?
Yeah, so with the management track, do you still do any hands-on work? How do you keep up to date with the advances? So I like this question. I think I sort of answered a question similar to it in our last talk, but there's this idea that when you're a manager, you stop being technical, and I think that's very misleading idea, especially in data science. I think I have to be more technical than I previously had to be, probably, at least in certain ways. And what I mean by that is I need to be able to, I am both the people manager and also a project manager. So I'm guiding the vision for how projects need to be implemented. And what that means is I need to understand all of the models that get built, all of the features that go into the models, all of the error analyses. So all of the work that a technical implementer needs to know how to do, but I also need to be able to translate those things to the business, right? So we have a metric. Let's say we achieve an AUC metric of a particular value. What is that going to mean for the end users, the business stakeholders? How is that going to translate into the metrics and KPIs that they care about, right? How are the models going to be used in their processes? So there are a lot more considerations to take. Now, in terms of if by hands-on you mean do I write the code? Personally, I don't write much code anymore. I've spent a lot less time, in a Jupyter notebook or in the R Markdown file. That said, I have regular meetings with people on my team where, I ask them for specific analyses and for specific plots and for specific metrics. They do the work of computing those things. They bring it to our meeting, and then we discuss those things. We iterate on it from there. So it's very, very hands-on in the sense that I'm not far removed from the outputs of the work, but I'm not actually writing the code myself. So I think this requires a lot of technical skills. If I didn't have my technical experience, I wouldn't be able to do my job the way I'm doing it now. So it's still very, very technical. Now, the second part of your question, I think, is also very interesting, which is how do you keep up to date with the advances? And I think the reality is I do much less keeping up with the advances than I used to do. So I find that, maybe for two good reasons. One is that there's just not enough hours in the day, right? And a lot of, machine learning and data science is sort of exploding. Like even from last year, when I look at the number of libraries out there or the number of blog posts being published on topics that very few people were writing about last year, it's certainly exploded. So I don't think it's realistic to expect for you to be able to follow all of the advances in data science. I spend much more of my time learning just about general management, and I think that benefits the people on my team, right? Part of the reason why I slowed down on my ML and production work is because I doubled down on my management responsibilities, and the reason I did that is because I want to become a better manager, but two, that's what my role requires, right? Previously, how I provided value was on actually doing sort of individual analyses or building individual models. And I think that required much more knowledge of sort of what was, the bleeding edge than my role today requires. Now, my data scientists are required to do that sort of research and to keep abreast of the latest developments. But my job is to make sure that we're achieving sort of the business outcomes. And I think that requires a little bit of less emphasis on what the bleeding edge of technology is, and more on how to properly manage projects, hit deadlines, hit goals, and make sure that people are happy. Right? I measure my success based on two things, and equally weighted. One is, are we achieving the goals of the business, and two is, are the people on my team satisfied with their jobs?
That's that was a great question, great answer as well. Thanks. Let's. So I'm seeing that since I said that people should upvote, there's been a change in the order. I think that the next most upvoted question is the one by Hafiz.
Yep.
Would you expect chief data scientist to be an expert in AI plus coding plus engineering, or someone who's more of a generalist?
I think that's also a great question, and I think it's very easy to have different opinions on this. My opinion on this is that for something as specialized as data science, you definitely want somebody who can at least speak the language and understand the major trade-offs. So this person doesn't need to know anything about neural networks, I think. And if he or she relies on a strong sort of middle management team, of which I would say I'm a middle manager, who know these things, then I think that's more than satisfactory if that chief data scientist still understands the fundamentals of what goes on. But similar to my response to the last question, where I spend less time following the bleeding edge, most up-to-date technology advances, I would expect that my manager and his or her manager to spend even less time investigating those things, right? Those people are really focused on the business. What are the goals of the business? What are the challenges the business is facing? But what I think is required is that the chief data scientist or the head of the department can have a conversation, can translate between the other executives within the company who aren't a data specialist and the folks on this person's team who are the data scientists and are the data science specialists. So I think being a generalist is fine, but I think there's a certain level of fundamental understanding of data science that can't be ignored. But I think what this person can really provide is an understanding of the business, and also an understanding of what the minimum level of predictive performance models can attain that can actually provide value, right? I found that this person, if he or she is very good at sort of understanding like what the minimum bar for a model is to impact business value, that can be really beneficial for a team. And that can actually help with things like timelines, which I see a couple of questions about timelines and like uncertainty in projects. I think if this person can responsibly lower the minimum acceptable threshold that a model needs to achieve by understanding really the process that the model will be deployed in and used in, then that person is extremely helpful for the team in general.
I'm seeing that we've got only 3 minutes left. So it's going to be a challenge to answer all 15 questions. And actually, there were more things that we wanted to talk about. I think we haven't touched on building versus buying and expanding your data science practice. Hey, we could do another one of these. We could do that for episode 3, right?
I think we need an episode 3.
Yeah, we need episode 3. And I think that it's also a great source of inspiration to have a look at these questions. So we can pick up on that in episode 3. I have no idea when episode 3 is going to be, but I think that there's some really good questions here. So I think that we should keep them for that time, and keep the other topics, as I said, for next time. When should we do this again? We need to speak, Luigi, but